Okay, so we'll start off with problem number one. And pretty much this whole exam deals with the material in chapter 2. And it says here in problem number 1, the function S of t represents the position of an object at time t moving along a line. And suppose S of 3 is equal to 116 and S of 6 equals 161. And here I want to find the average velocity of the object over the interval of time from 3 to 6. Okay, so here we're given that S of 3 is equal to 116. And we're also told that S of 6 is equal to 161. And we have the interval from 3 to 6. And we're told to find the average velocity. So that average velocity function, which is this, equals this, S of B minus S of A, and the whole thing's divided by B minus A. And in this case here we have the interval 3, 6, so that means your A has to be 3 and B has to be 6. So if we simplify that, that's just going to be S of 6, because that's what B is equal to, minus S of A, and A is 3. All that's divided by 6 minus 3. Well, S of 6, that's given to be 161, minus S of S of 3, that's 116, over, and I'll go ahead and do 6 minus 3, which is 3. So if I subtract 116 from 161, I should get, 45. And if I divide 3 into 45, I would end up getting 15. So the average velocity of an object over an interval of time from 3 to 6 would be 15. Okay. All right. Are there any questions about number 1? All right, number 2 is using the graph that's given to you to find the following values, if they exist. So here we're dealing with values at h, and also we're going to be dealing with limits as well from a graph. So in this case here in part A, we just need to find out what h of 5 will be. So we're finding the value of the function h of x when x is equal to 5. Okay, so here's 5 right here. And we do have a point at 5. So when x is 5, the value of h of x will be 8. So that means h of 5 would be 8. Okay. Questions on part A. Now part B is finding the limit as x approaches 5 of the function h of x. Okay. So from this graph, we have to look at what's happening with this function when we approach 5 from the left side and approaching 5 from the right side. All right, so if we approach 5 from the left, here's 5. If we're coming from the left of 5, that means that h of x, the value of h of x, would get closer and closer to 6. And to the right of 5, also going to 6, because here's 5, we're coming from the right. That means that these values of h of x gets closer and closer to 6. So the limit as x approaches 5 of h of x will end up being 6. Okay. All right, questions about part B. All right, now part C is the limit, well, actually h of 7. H of 7. So we need to know what the value of this function when x is equal to 7. And notice in this case, at 7, we have an empty circle. So that means that h of 7, the value of that function when x is equal to 7, does not exist. Now, if you want to, you can write the letters D, N, E, but does not exist. So the value of that function when x is equal to 7 does not exist. Okay. All right, now part D is the limit as x approaches 7 of h of x. So in this case, here's 7 right here. Now, as we approach 7 from the left side of 7, these values will be approaching what number? 3. Okay. And what about to the right? Also 3. You can see that getting closer and closer to 3 on both sides. So that means that the limit as x approaches 7 of h of x would just be 3, but it won't get to 3. Okay. And then part E is the limit as x approaches 8 of h of x. And here's 8 as we come from the left of 8. Or at 8, what would be that value? 4. Okay. Because to the left of it is getting closer to 4, and to the right of it is getting closer to 4. But of course, at 8, it's going to be 4. So the limit as x approaches 8 of h of x will be 4. Okay. Any questions about problem number 2? On problem number 3, you have, in this case, f of x is equal to x squared minus 25 divided by x plus 5. And here we're going to calculate f of x for each value of x in that following table, and then make a conjecture or conclusion about the value of the limit as x approaches negative 5 of x squared minus 25 divided by x plus 5. Okay, so I'm going to go ahead and recreate that table. So I know at negative 5, there's going to be error, because we know at negative 5 we'll get a 0 in the denominator. All right, so now let's look at numbers like negative 4.9999, then negative 4.99. then negative 4.99. That's as we approach negative 5 from the right. And then from the left, be negative 5.0001, then negative 5.001, negative 5.01, and finally negative 5.1. Okay. So now I'm going to use my graphing calculator to do this. Now here we can enter this function into our graphing calculator. So I'm going to go to y equal 2, and then I'm going to clear this equation out that I have in y1. The numerator and the denominator I will put in parentheses. So for the x squared minus 25 will be left parentheses, get the x and then square it, minus 25, close parentheses, divided by the x minus 5, x plus 5 will be in parentheses as well, so left parentheses, xt theta for the x plus 5, close parentheses. And I'm also going to clear this equation that's in y2 out. Yep. All right, so now, for the table, we just press the second key and graph for the table. Okay. Let me do a table set here, second table set. Actually, let me do this. Under independent, I'm going to highlight the word ask because I want this calculator to ask for the x value. So let me use my right arrow key under independent and press enter for it to ask. And then do second table. Okay. So for negative 5.1, I'll just type in negative 5.1 and then hit enter. And here I get negative 10.1. And then for negative 5.01, that'd be negative 10.01. And then for negative 5.001, okay, let me use my up arrow key and use the right arrow key to get the exact y1 value for that. It'll be negative 10.001. And then finally, go back under the x and do negative 5.0001. Then up arrow, right arrow, it'll be negative 10.0001. Okay. Now, we'll look at these numbers. And I'm going to start with negative 4.9. So right arrow and then the left arrow, negative 4.9. Oops. Negative 4.9. That's going to be negative 9.9. And then for negative 4.99, that'd be negative 9.99. Then negative 4.999, that'd be negative negative 9.999. And then finally, negative 4.49. Actually, it says negative 10, but it's actually negative 0.99, negative 9.9999. So, what value do you think that this will be approaching? Just negative 10. Because on the left of negative 5, those values are getting closer and closer to negative 10. And to the right of negative 5, it's getting closer and closer to negative 10. So, this is part A. That's the table. Part B is the conjecture that the limit as x approaches negative 5 of x squared minus 25 divided by x plus 5 would be negative 10. So on the test, you will have a table to complete, and then you'll make your conjecture, which is part B, about the limit as x approaches -5 of that function. All right, questions on number 3. All right, number 4 is computing limits using the limit laws in section 2.2. And in this case here, you're going to evaluate the following limits. Now, some of these are going to be pretty much by direct substitution, if that is possible. So in part A of number 4, we have the limit as x approaches -2 of the quantity 7x plus 1. Now, in this case here, we have a linear function. And in a linear function, we can always use direct substitution when we're taking the limit here. All right, so we just replace your x with that -2. So that means it'll be 7 times x, which is -2, plus 1. 7 times -2, that's -14. -14 plus 1 ends up being -13. Okay. Any questions about part A? All right, now part B is the limit as x approaches -6 of pi. Well, pi is equivalent to 3.1415927, and so on, which is a constant. And one of the limit laws is this, that the limit of any constant will always be that constant. So if I take the limit as x approaches -6 of pi, it would just be pi. That'd be your answer right there. All right, any questions about part B? Part C is the limit as x approaches -1. 2x cubed minus 5x squared plus 4x plus 8. So again, we have well, this time we do have a polynomial function. So with a polynomial function, you can always take the limit by using direct substitution. So here I can just substitute every x in that function with -1. So this will be 2 times x, which is -1, and that's cubed, minus 5 times x, which is -1, and that's squared, plus 4 times x, which is -1, plus 8. Okay, now I know a negative, this is going to be easy. -1 to an odd power will be -1, and -1 to an even power will be +1. So here, if I cube -1, that'd be -1 times the 2 in front, which would be -2, minus square the -1, that'd be +1 times that -5 will be -5. Plus 4 times that -1 would be -4 plus 8. And if I simplify -2 minus 5, that's -3. -3 minus 4 would be -7. Wait a minute, that's -7 here. -2 minus 5 would be -7. -7 minus 4 would be -11, and -11 plus 8 would be -3. So the limit as x approaches -1 of 2x cubed minus 5x squared plus 4x plus 8 would be -3. Okay. Any question about part B? Part C. All right, part D looks like this. The limit as x approaches 1 of 5x squared plus 8x plus 2. All that's divided by 7x minus 2. In this case here, as long as I don't get a 0 in the denominator for this rational function, I can use direct substitution. And in this case here, if I replace that x with the 1, I won't get a 0 in the denominator. So I can apply the direct substitution here. So this means I can do 5 times 1 squared plus 8 times 1 plus 2 in the numerator. The denominator will be 7 times the quantity, 7 times x, which is 1, minus 2. Now, if I simplify that numerator, 1 squared will be 1 times the 5 in front will be 5, plus 8 times 1 is 8, plus 2, divided by 7 times 1 will be 7, minus 2. And if I add 5 and 8, that would be 13. 13 plus 2 will be 15. The denominator, 7 minus 2, will be 5. And 15 divided by 5 will end up being 3. So the limit as x approaches 1, 5x squared plus 8x plus 2 divided by 7x minus 2 would be 3. Questions on part D? All right. Let's see, part E looks like this. Here we got the limit as x approaches 4. Of x squared minus 2x minus 8. And all that's divided by x squared minus 4. X minus 4. Now we have a problem here with direct substitution. At 4, I would get a 0 in the denominator. So the next option would have to be, for something like this, I need to factor and divide out those common factors in this case. Let's see if I can factor x squared minus 2x minus 8 into two binomials. Oops. But before I do that, I need to bring this notation over the limit as x approaches 4. And then we can see if we can factor the numerator into two binomials. Well, that x squared breaks up as x and x. Factors of negative 8 that would give me negative 2 as a middle term will have to be 1, 2. But the larger of the two factors will have to take the sign of that middle term here. The larger factor is 4, so that means it has to be a minus 4. The 2 will have to be plus. So I have the limit as x approaches 4 of x minus 4 times x plus 2 divided by x minus 4. And as you can see here, these x minus 4s divide out. So here we can divide out those common factors. So this will be the limit as x approaches 4 of just x plus 2. So now we've reduced that to just a linear function, which means I can use direct substitution. So here I can replace that x with 4, so it'll just be 4 plus 2, and it ends up being 6. So the limit as x approaches 4 of x squared minus 2x minus 8 divided by x minus 4 will end up being 6. Questions about part E? Okay, part F looks like this. The limit as x approaches 441 of the square root of x minus 21 divided by x minus 441. All right, now, of course, factoring and dividing out common factors would not work. And also, direct substitution would give us a 0 in the denominator. So we're going to have to multiply the numerator and the denominator by what they call the conjugate of either the numerator or the denominator. It'll be best to take the conjugate of our numerator. So in this case here, if I multiply the numerator and the denominator by the conjugate of that numerator, well, the conjugate is just this, using those same terms and just changing the sign to the opposite. So if it's a minus, we change this to a plus. So we'll multiply the numerator and the denominator by the square root of x, then plus 21. So the limit as x approaches 441 of, now in this case here, that numerator, I'm going to have to apply the sum, add the sum of the difference of the same two terms. I'll do this by squaring the first term. That means the square root of x times the square root of x. That'd just be x. And keep in mind that the square root of x, and you square it, the square eliminates the square root symbol. So you're left with x minus the square of the second term, minus 21 times a plus 21. That would give you 441 in the numerator. This will be divided by, and I'm going to put the x minus 441 in the parentheses, and the square root of x plus 21 also in parentheses. So now you can see here that x minus 441 divides out. So that means I have a limit as x approaches 441. Now here I'm going to have a 1 in the numerator. And in the denominator, I'm left with the square root of x plus 21. Now, since I will not get a 0 in the denominator, I'll go ahead and replace that x with the 441. So that means I have 1 divided by the square root of 441, and then plus 21. Now the square root of 441 is 21, and 21 plus 21 would give me 42 in the denominator. So that means that the limit as x approaches 441 of the square root of x minus 21 divided by x minus 441 will end up being 1 over 42. Are there any questions about problem number 4, A through F? Okay, problem number 5. Here you have the graph of F shown, and it has vertical asymptotes at x equals 2 and x equals 6. You're going to find the following limits, and then you're going to use infinity or negative infinity where appropriate. So in part A, you have this. The limit as x approaches 2 from the left of f of x. So we're looking at the left of 2. So here's 2 right here. That's that vertical asymptote. When you approach 2 from the left side of 2, these values here for f of x will be going off to where? Negative infinity, because it's going downward indefinitely. So it'll be infinity. Okay, so that's part A. All right, now part B is the limit as x approaches 2 from the right of that function f of x. So here's 2 right here. As we come from the right of 2, these values of f of x will be shooting where? Positive infinity. Okay, so that right there is part B. And now part C is a limit as x approaches just 2 of that function f of x. All right, so now take a look here. Yeah, the limit as x approaches 2 from the left is going to negative infinity, and then 2 to the right is the limit of that function going to infinity. So it's going off to 2 different places. For the limit to exist, it has to be going to the same place. Here it's going to 2 different places, so that means the limit as x approaches 2 of this function, I'm just going to say dne, for does not exist. All right, questions about parts A, B, or C? All right, now part D is the limit as x approaches 6 from the left of that same function f of x. Okay, so this is the other vertical asymptote. Here's 6. So if we're coming in from the left of 6, the function values for f of x would be going where? No. Take a look carefully. Positive infinity, because it's going up, up, without any, without end, or without bound. So it's going to be positive infinity. Now part E is the limit as x approaches 6 from the right. That same function f of x. So here's 6. To the right of 6, these values of f of x is going to positive infinity because it's going upward without bound. So it's positive infinity. Yeah, because if you're coming in from the right, it's going upward without end. So it's up to positive infinity. All right, so now part F is the limit as x approaches 6 of that function f of x. To 6. All right, take a look at these two. Are they going to the same place? They are. So the limit as x approaches 6 of that function goes to infinity as well. All right, are there any questions about problem number 5? Okay, number 6. All right, here we're just going to be looking at limits here. Sometimes we may have to factor and divide our common factors. Sometimes we may have to divide every single term in the numerator and the denominator by the highest exponent in that denominator. And there are some rules that we talked about as well. So let's start with part A, finding the limit as x approaches 0 of x cubed minus 2x squared divided by x squared. And they do give you a hint to simplify the expression inside the limit. And we might need to use does not exist or DNE if that limit doesn't exist. So in this case here, let's see if we can simplify this. In x cubed minus x squared, there minus 2x squared, x cubed minus 2x squared has a common factor in it. What do you think that would be? Common factor, x squared. Because x is in both of them, we take the one with the smallest exponent. So x squared would be a common factor. And then do x squared, x cubed divided by x squared, that would be x minus 2x squared divided by x squared would just be 2. Oh, that's divided by x squared. All right, so as long as x squared does not give me a 0 in the denominator, I can divide that out and take the limit as x approaches 0 of x minus 2. And of course, here we can just use direct substitution, so it'll be 0 minus 2, which is in this case, negative 2. Are there any questions about part A? Now, part B, we have the limit as x approaches infinity of 9x cubed minus 2x squared plus 3x. That whole thing's divided by negative x cubed minus 2x plus 7. All right, now the way we're going to have to solve this problem, we're letting x approach infinity this time. That means we're going to have to divide each and every single term in the numerator and denominator by the highest exponent in that denominator. Here we got an x, the highest exponent there is a cube. So we need to divide every single term in the numerator by x cubed and every single term in the denominator by x cubed as well. So I'm going to bring over the limit as x approaches infinity of, let's see, 9x cubed will be divided by x cubed, and then minus 2x squared will be divided by x cubed, plus 3x will be divided by x cubed. Then that's going to be divided by, let's see, negative x cubed will be divided by x cubed, minus 2x will be divided by x cubed, plus 7 divided by x cubed. Okay, now I'm going to bring that, still bring down that notational limit as x approaches infinity of. Now 9x cubed divided by x cubed reduces to 9 minus 2x squared divided by x cubed. I have a 2 in the numerator, but 2 of those x's are gone. I'm left with an x in a denominator. And then plus, let's see, I still have a 3 in the numerator. One of the x's will divide out with that x cubed, leaving me with x squared. Then that's divided by negative x cubed divided by negative x cubed divided by x cubed, that's negative 1. And then minus, one of the x's will divide out with the x cubed. I have a 2 in the numerator, but an x squared in the denominator. And I have nothing to divide out there with that 7 over x cubed. Okay. Now let's go ahead and take the limit. Well, the limit of a constant is going to end up being a constant. So the limit of 9 will be 9. And then the limit of a negative 1 will be negative 1. But for the rest of these, as we let x approach infinity, 1 over x to whatever my exponent is will be getting closer and closer to 0. So these terms right here will get closer and closer to 0 because of that rule that says that if you take the limit as x approaches infinity, both positive or negative, of 1 over x to the n power, it's going to get closer and closer to 0. So I'll end up with 9 over negative 1, or just negative 9. So the limit as x approaches infinity of 9x cubed minus 2x squared plus 3x divided by negative x cubed minus 2x plus 7 ends up being negative 9. All right, questions about part B? Okay, part C. Okay, I'll tell you what. Because I know there's a lot of writing there. Okay. All right, now part C. Here we got the limit as x approaches in negative infinity, 3x raised to the 17th power. Okay. I'm going to use one of those limit laws where if you have the limit of a constant multiplied by some variable, I can pull the constant out in front, so it'll be 3 times the limit as x approaches negative infinity of x to the 17th power. And I'm going to concentrate on this right here. That x is to an odd power, and we're letting x approach negative infinity. So if you have an odd power, then the limit as x approaches negative infinity of that will go to okay. And 3 times negative infinity, well, it's going to end up being negative infinity because it's just going to go to negative infinity 3 times as fast. So the limit as x approaches negative infinity of 3x to the 17th power would just be negative infinity. Now, part D is just a limit as x approaches negative infinity again. This time we have a polynomial function 5x to the 7th minus 6x to the 6th plus 1. Now, when you have a polynomial function like this, let's just take the limit as x approaches negative infinity of the leading term. That's going to tell us where this will be going, 5x to the 7th. Well, it's x approaching negative infinity, and we have an odd power, so that means this will have to go to negative infinity. If that had been an even power like 5x to the 8th, then as we let x approach negative infinity, that limit will be going to positive infinity. Any questions about problem number 6? All right, number 7 is this. We're going to evaluate the limit as x approaches infinity of f of x and the limit as x approaches negative infinity of f of x for each function, then give the horizontal asymptote of the function f, if any. Okay, so that's how we evaluate limits to find out our horizontal asymptotes, if there is one. So in part A, we got f of x equaling to 6x squared minus 8x plus 7. Whole thing's divided by 2x squared plus 1. And we want the limit as x approaches infinity of f of x. So here we're finding the limit as x approaches infinity of that 6x squared minus 8x plus 7, all divided by 2x squared plus 1. Well, probably the best way to solve this problem would be to divide every single term in the numerator and the denominator by the highest exponent in the denominator. And in this case, x squared is your highest, has the highest exponent. So we'll take 6x squared, divide that by x squared, minus 8x. Divide that by x squared, plus 7, divided by x squared. All that's divided by the 2x squared will be divided by x squared, plus 1 will be divided by x squared. Now put all of this inside the bracket to indicate I'm taking the limit of the whole thing. Now, simplify what's inside that bracket. I'm going to bring down the limit as x approaches infinity of 6x squared divided by x squared, that's 6, minus, I have an 8 in the numerator, but one of the x's will divide out. I'll be left with an x, and then plus 7 over x squared. Divide that by 2x squared divided by x squared will leave me with 2, and the 1 would just be 1 over x squared. All right, so now let's go ahead and take the limit. The limit of this constant will be a constant, and the limit of that constant in the denominator will be a constant. So I have a 6 over 2, but as we let x approach infinity, these rationals, 8 over x goes to 0, 7 over x squared also goes to 0, and 1 over x squared will also go to 0. Okay, so now I'll be left with 6 divided by 2. That'll end up being 3. Okay, so that's the limit as x approaches infinity. Now what about negative infinity? Of f of x. Which means if I take the limit as x approaches negative infinity of 6x squared minus 8x plus 7 divided by 2x squared plus 1. Well, if I go through that, go through dividing every single term in the numerator and the denominator by that x squared, I'm going to end up getting the same thing after taking the limit. So the limit as x approaches negative infinity of this function will also be 3. Because I know the fact that as x approaches negative infinity, these terms right here will be going closer and closer to 0. So as x approaches negative infinity, the limit of that function will be 3. So they're both going to the same number, so that means that will be your horizontal asymptote right there for this function. And that would be the equation y is equal to 3. And do make sure you include y equals 2 because the horizontal asymptote is a horizontal line. And it's y equal to for that horizontal line. Are there any questions about part A? Okay. Part B looks like this. Let's see, we got f of x is equal to 41x to the 6 plus 2x squared divided by 16x to the 5th minus 2x. Let's find the limit as x approaches negative infinity of f of x, and f of x will be this. I'll just go ahead and rewrite that. Let's say x approaches infinity. Okay, just infinity. All right, so we're going to divide every single term by the highest exponent in the denominator. In this case, the highest exponent is x to the 5th. So we'll divide every single term by x to the 5th. So I have 41x to the 6th divided by x to the 5th plus 2x squared divided by x to the 5th. That'd be divided by 16x to the 5th divided by x to the 5th minus 2x divided by x to the 5th. So if I take the limit as x approaches infinity of 41x to the 6th divided by x to the 5th, I'll be left with 41x plus 2 of the x's will divide out. I'll have a 2 in the numerator, and I'll be left with an x cubed in the denominator. 16x to the 5th divided by x to the 5th would leave me with 16 minus 1 of the x's will divide out. I'll be left with a 2 and x to the 4th in the denominator. Now, the only thing I'm going to be left with is this. The limit as x approaches infinity of 41x over 16. And the reason for that is, as we let x approach infinity, the 2 over x cubed will go to infinity, and 2 over x to the 4th also goes to 0. They both go to 0. Okay? And that 41 over 16 is a constant. As x approaches infinity, this x will be going to infinity. And 41 over 6 times infinity ends up being infinity. Okay. Now, let's take the limit as x approaches negative infinity of 41x to the 6th plus 2x squared divided by 16x to the 5th minus 2x, which is what f of x is. Well, guess what? This part right here, when I divide every single term by x to the 5th, like I did up here, will end up being 41x over 16. So let's use that. And then this time, the constant 41 over 16, as x approaches negative infinity, this x goes to negative infinity. And negative infinity times 41 over 16 ends up being negative infinity. Now compare the two. As we let x approach positive infinity, it goes to positive infinity. As we let x approach negative infinity, the function will go to negative infinity. They're going to two different places. So that means that this graph of this rational function has no horizontal asymptote. Okay? No horizontal asymptote. Now, if you want to, you can say that this does have a slant asymptote because the highest exponent in the numerator is one more than the highest exponent in the denominator. But there you can just say no horizontal asymptote as your answer. All right, question about problem number 7. All right, let's look at problem number 8. This is where we use the continuity checklist to determine whether a function is discontinuous at the indicated value. Okay, so here's the graph. So using the continuity checklist, we have to determine if the function is continuous at the indicated value. In part A, is this function continuous at x is equal to 3? Well, let's look at 3 right here. The 3 things we need to know is this. Is the function defined at that x value? That's the first thing. So we look at f of 3. So at 3, we have a y value of 1. And then the limit as x approaches 3 of that function must exist. Let's take a look at 3. As we come from the left of 3, these f of x values are getting closer and closer to what number? 2. And as we come to the right of 3, these f of x values are getting closer and closer to 1. So here they're going to two different values here. So we can say here that the limit does not exist. And we can end this problem right here. Because if it fails one of those three different rules, then that means that the function is not continuous at that value. So here, your function f of x is not continuous. At x equals 3. Okay. Are there any questions about part A? All right, now part B, they ask, is the function continuous at x equals 5? Well, let's find out what f of 5 is equal to. So here's 5 right here. At f of 5, what would be my f of x value? 3. So f of 5 is 3. So there is a value for that function at x equals 5. Now for the limit as x approaches 5 of f of x. Let's see what's happening here on both sides of 5. On the left of 5, the values of f of x get closer and closer to 3. And to the right of 5, the values here get closer and closer to 3. So the limit as x approaches 5 of f of x is 3. And then the last question is going to be this: is the limit as x approaches 5 of f of x equaling to what f of 5 is? Are those two equal? Yeah. So that means this satisfies the continuity test. So that means that f of x is continuous at x is equal to 5. Okay. So that's what we mean by that continuity checklist or continuity test. All right. Are there any questions about problem number 8? All right, problem number 9 is determine the intervals in which each function is continuous. All right, so in part A, we got p of x is equal to 7x to the 6 plus 4x squared plus 9. Let's see if it's continuous. And it is a polynomial function, so that tells me right off the top that any x value that you assign to it, you will always get an f of x value for it. So that means that it is continuous on and we'll write this in interval notation. Infinity to infinity. Negative infinity to infinity means all real numbers. Every real number will satisfy that p of x function. All right, questions on part A. Part B, f of x is equal to 4 divided by x squared minus 25. find out what values of x that will make the denominator 0. So what I need to do here is just take that denominator of x squared minus 25, set that equal to 0. Okay? And then solve for x. Let's see. If I add 25 to both sides, that means that x squared is equal to 25. Take the square root on both sides and include that plus or minus symbol. That would mean x is equal to plus or minus 5. So at x equals 5 and x equals negative 5, I would get a 0 in the denominator. And of course, this is not required, but you can draw a number line to find out what your interval notation would look like. So you 0, 5, negative 5. At those two x values, we know we're going to get a 0 in the denominator. Anything less than negative 5 would work. Anything in between, any x value in between negative 5 and 5 would work, and any x value greater than 5 would work. So this function is continuous if you are to use interval notation. Negative infinity to negative 5, or from negative 5 to 5, or from 5 to infinity. Okay. Any questions about problem number 9? All right, now finally problem number 10. Let's say we use that intermediate value theorem to show that the equation x cubed plus 4 plus x plus 3 equals 0 has a solution on the interval negative 2 to 1. Then use the graphing calculator to find all the solutions to the equation on that given interval. Okay, so here we got the function x cubed plus x plus 3 equal to 0, and the interval is from negative 2 to 1. So this part is the f of x, and this part is the L. Okay. So that means we want to find out what values of x where f of x will be equal to the limiting value L, in this case, which is 0. And in this case, let's look at that x cubed plus x plus 3, which is what I'm letting f of x be. So here f of x is this. I know that it's continuous everywhere on the interval from negative infinity to infinity because it is a polynomial function. For every polynomial function, every x value has an f of x value for it. All right, next I'm going to find the values of each endpoint. If there is a change in sign, of course, for my f of x values, that means that there is a 0 there. So if I evaluate f of negative 2 and f of 1, if I have a change in sign, well, one is negative, the other one's positive, that means that there is a 0 somewhere between negative 2 and 1. So let's start with f of negative 2. This will be negative 2, and that's cube, plus negative 2, plus 3. Simplify negative 2 cubed, that would be negative 8. Plus negative 2 would be like minus 2 plus 3. And then negative 8 minus 2, that'd be negative 10 and then negative 10 plus 3, negative 7. And now for f of 1, we just simply replace the x with the 1 in that function and simplify. Negative 1 cubed will be 1 plus 3. Ends up being 5. So here I got a negative 7 and a positive 5. So here I have different signs here. One's negative, the other one's positive. That means that there is a 0 between those two endpoints, negative 2 and 1. So a 0 does exist. And that's because 0 is between negative 7 and 5. Now we're going to find out what that x value is using our graphing calculator. So I'll just say here, use the graphing calculator to find the x value such that f of x equals 0. Okay, so let's use our graphing calculator for this. Okay, let's do this. I'm going to go to the window, take that back, second table set. I'm going to go back to independent and highlight auto. Okay, and then I'm going to go to y equal 2, clear this equation out, and then type in, let's see, x cubed would be x, the hat key, and then 3. Right arrow to guide the exponential part, plus x c theta n for the x, plus 3. And I'm also going to do, let me see if I can do zoom 6. Okay. So we know there's a 0 somewhere, which is right here. There's only one value of x, where f of x would be equal to 0. So let's do this. I'm going to do second. Also, let me go back to y equal 2. Okay. Y equal 2. That L, which was 0, under y2, I'll put 0 here as well. All right. Now zoom 6. Now I'm going to find the intersection of the two. So I'm going to do second and trace for the calculate menu. I'm going to find the intersection, so I'm going to select number 5 for the intersection. Now, I'm going to use my blinking cursor to use my left arrow key to put that blinking cursor as close as I can to that point of intersection. Because here's y equal to 0, which is the x-axis. And the graph, I'm finding the intersection of the two. Then I'm going to press enter 3 times. And to 3 decimal places here, that x value, where f of x is equal to 0, is approximately negative 1.213. Okay. So that is the value of x such that f of x would be equal to 0, negative 1.213. Are there any questions? Okay, so that's basically what you will see on your exam number 2 on Friday. And do make sure that you do have just a one sheet of notes with front and back writing. And make sure you do bring your own calculator to class with you and something to write with.